Hi class, this is Mrs. Lyons. Today we're going to start Unit 2 by talking about the particles that make up the atom. Alright, hopefully this is a review for you, but there are three subatomic particles. The first one is the electron. Electrons have a -1 charge. The second subatomic particle is the proton. Protons have a +1 charge. And oftentimes you'll see this symbolized. You'll see us abbreviate the electron with an E with a negative sign. You'll see us abbreviate proton as a P with a plus sign. Okay, so shorthand. The neutron is a neutral particle. It has a 0 charge. Okay, so we'll see that abbreviated N with a 0 for giving it a neutral charge. All right. When we talk about the mass of these particles, they're very, 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 very tiny masses, okay? And they're so little that we assign them special units, okay? So for the neutron, we say that the neutron has a mass of 1 AMU. AMU is atomic mass unit. The proton has the same relative mass, 1 AMU. And then the electron, because it's so tiny, teensy tiny, we know that it has an actual mass, but we assign it a 0 relative mass because compared to the proton and compared to the neutron, it's so small that its mass doesn't matter, so to speak. Okay, the location, the electron is located outside of the nucleus. In an electron cloud. The proton and the neutron are found in the center of the atom inside the nucleus. Okay. The atomic number. This is a number that is assigned to each element, and every element has its very own unique atomic number. The atomic number tells us the number of protons in the nucleus of that particular atom of that element. If we look at the periodic table, the atomic number is the number on the top of the square. So if you look on your periodic table, find carbon, which is abbreviated C. If you look, there's a number above the C, the symbol. That number is a 6. That is the atomic number, and that equals the number of protons. If you look at phosphorus on the periodic table, phosphorus is element number 11. That means it has 15 protons in its nucleus. Phosphorus is abbreviated P, just in case you're having trouble finding it. Gold is abbreviated AU. And if you look, gold is element number 79. Means its atomic number is 79. The number of protons is 79. One thing to keep in mind, we're not really talking about it here, but we can also figure out the number of electrons by looking at the number of protons, because the number of protons is equal to the number of electrons. And that's because protons are positive, electrons are negative. Our atoms are neutral. Okay, so the positive and negative charges have to add up to 0. This means we have to have the same number of protons as we have electrons. The mass number. The mass number, real quick, let me say this. This is important. The mass number is not found on the periodic table. Okay, you cannot look at the periodic table and find the mass number. My pen is screwing up. I apologize. The mass number is the number of protons plus the number of neutrons in the nucleus. All right, so we might write this mathematically. The mass number is protons plus neutrons. So let's look at this. We call atoms, when we're talking about mass number and atomic number, we call them nuclides. And then we're looking for the number of protons, the number of neutrons, and the number of electrons. And then we also want to know the mass number. Okay? Now, in this first example, we've got oxygen. If we look at our periodic table, oxygen is element number 8. That tells us that it has 8 protons, which means it has 8 electrons. Now that we know the number of protons and the number of neutrons, we can add them together to give us the mass number of 18. One thing that we do, we write something called hyphen notation for the element. And this, for oxygen, and for this isotope, and I'll tell you what an isotope is in just a minute, for this isotope of oxygen, we would write that this is oxygen 18. That's how we know what the mass number is. All right, look at this second example. It tells us it has 33 protons. Well, we automatically can figure out that if it has 33 protons, it also has 33 electrons. What would the mass number be? The mass number would be the amount of protons plus neutrons. So the mass number would be 75. So what element would this be? How do we figure out which element this is? Hopefully, you said we look at the periodic table. We look at element number 33, which is abbreviated AS. If you look at the name, it's called arsenic. And arsenic, we need our hyphen notation, we need the mass number here, so it would be arsenic 75. All right, last example. I give you, we have the number of protons. We have, what's this? This number? This number is the mass number. So we can put that right over there right away. Now, what else do we know? We know that the number of protons equals the number of electrons, so electrons is 15. This is element number 15, which, oh, we have another phosphorus example. So element number 15 is phosphorus 31. The only thing we have to do is figure out number of neutrons. How do we do that? Hopefully, you said, we take the mass number and subtract the number of protons. This will give us the number of neutrons. Okay, so you should be able to, given a hyphen notation element, or given the number of protons, neutrons, you should be able to figure these things out. We'll do a lot of practice on this in class tomorrow. Now, as I promised, let's define another term, isotopes. Isotopes are interesting because we know, we've already said that all atoms of the same element have the same number of protons. Okay, so the number of protons in every hydrogen atom is 1. However, some atoms of elements have different mass numbers, different masses, and this is due to a different number of neutrons. Okay, since neutrons are neutral, we can just add neutrons and the mass changes. So let's look at an example of hydrogen. There are actually 3 isotopes of hydrogen that occur naturally in nature. Hydrogen 1, which is called protium, hydrogen 2, which is called deuterium, and hydrogen 3, which is called tritium. What's the difference in these? Let's take a look. They each have 1 proton. That's what makes them hydrogen. Since they have 1 proton, they're neutral, they each have 1 electron. So far they're all identical. But remember, this number tells us the mass of the atom. And that's the number of protons and neutrons combined. So the isotope hydrogen 1, we have 1 proton. The mass number is 1, so we have 0 neutrons. So the nucleus of a protium atom is just simply a proton. In hydrogen 2, deuterium, mass number is 2. We only have 1 proton. That means the rest of this mass has to be made up by 1 neutron. So our nucleus has 1 proton, 1 neutron in it. Tritium, hydrogen 3, still 1 proton, mass number is 3. That tells us there are 2 neutrons. So if we look at the nucleus of this, it's got 1 proton and then 2 neutral subatomic particles, giving it 3 particles in its nucleus and a mass of 3. Okay, so that's isotopes. The last thing we need to talk about are nuclear symbols, which are also called nuclide symbols. Okay, so you might see it 2 ways, nuclear symbols or nuclide symbols. And what this is, it is the element symbol, and then we write the mass number and the atomic number next to it. So for those 3 isotopes of hydrogen, we would write the symbol for hydrogen, H, and then that first hydrogen 1, the mass number is 1, the atomic number is 1. Deuterium, hydrogen 2, okay, atomic symbol, and then we know that the atomic number is always going to be 1. In this case, though, the mass number is 2, that 1 proton, 1 neutron. And then we have tritium, again, hydrogen, 1 proton, but it had 2 neutrons, so it's going to be 3. Okay, so this is how we write nuclear symbols. Okay, the mass number goes on top, the atomic number goes on bottom. Let's do an example. All right, so we have F fluorine 19,9. What is the number of protons? Remember, this is the atomic number. So that tells us that there are 9 protons in this atom. How do we figure out the number of neutrons? What's this number? This number is the mass number. So it's the number of protons plus neutrons. So 19 is protons plus neutrons. If we've got 9 protons, that means we must have, 10 neutrons. Number of electrons, that one's easy. It's the same as the number of protons, so 9. Atomic number is on the bottom, 9. Mass number on the top, 19. We are going to do lots and lots of practice in class on this. So hopefully by the time we get to the end of the day tomorrow, you will be a pro at counting subatomic particles and knowing atomic number and mass number. So let's just review real quick with the concept map. We have the atom. The atom is made up of the nucleus, which contains the positive protons, the neutral neutrons. The other part of the atom is the electrons, which are found in the electron cloud and have a negative charge, very little mass. Okay? One thing to keep in mind, when you look at an atom, we have this little tiny nucleus, very small, very dense nucleus. And then the electrons are found out here orbiting around the nucleus, okay, in electron clouds. Okay, and we'll talk exactly about how those clouds, what they look like, because they don't really look like this. But the thing I want you to recognize is that nucleus is really, really small. But the nucleus makes up most of the mass of the atom. Okay? Most of the mass is in the nucleus because the electrons don't have much mass. The thing to keep in mind is when we talk about the nucleus or the atom, we also have to talk about the volume. And this is important. The volume of the atom is mostly empty space. comparatively. Mostly empty space. That's because that nucleus is so small and contains all of the mass, and the electrons are zipping around relatively far from the nucleus. An example I like to give is if the nucleus were a golf ball placed on the 50-yard line of a football field, this electron cloud, where the rest of the electrons are, is the space the size of the football field. So think about that. The nucleus of an atom is a golf ball on the 50-yard line. Think about how big the football field is. All of that space basically is empty space except for a few electrons orbiting around it. All right, let's see. The number of protons is equal to the atomic number of the atom, and then finally, the protons and electrons are equal in a neutral atom. All right, that's it for today. Tomorrow's podcast will talk about average atomic mass. Until then, I will see you